Welcome to 13.1 Counting Principles. Today, or actually this chapter, we're going to be learning about the counting principle and how we figure out probability. This is basically the main thrust of what we're going to be doing. So, the first step is to learn about how to count different kinds of outcomes. All right, so all right, I'm going to have to make this just, whoops. All right, I don't want to do that. There we go. A little bit small, shift it over so I can see it all. All right, how many three-letter arrangements can you make with letters in the word cat? Well, let's see. If I anchor the C, I have A-T or T-A. If I have A come first, I have C-T or T-C. Then if I have T come first, I have AC or CA. So this gives me 6 possibilities. So if you notice, sorry, okay, this is something called factorial, but I'll explain that in a little bit. How many different 3-letter arrangements can you make with the letters in the word hope? Now notice there's 4 letters instead of just 3 letters, but we're still looking at 3-letter arrangements. So I have H-O-P, H-P-O, H. Here, let me not do the H there. The next one. Okay, my writing's terrible here. H-P-O. We have H-O-E and H-E-O. And then we have H, let's see, we haven't put P and E together. P-E and H-E-P. Now we know we have those 6 possibilities for 4 different first letters. Okay, so we have 6 possibilities for 4 different first letters. So our total possibility is 24. All right, how many different arrangements can you make with the letters of a word with 6 different letters? Okay, let's see. Basically, that's going to be, each letter is a first letter. Once I have each of those letters, there are 5 left that could be the second letter. And then there are 4 left that could be the third letter, 3 for the 4th letter, 2 for the 5th letter, and now there's only 1 left that could for the 6th letter. So this gives you all your possibilities, and you're going to multiply these numbers together. So we have 3 times 2 is 6, times 4 is 24, which is what we actually saw up here. And then we have times 5. So 24 times 5 is 120. Times 6. 120 times 6 is 60, 600, 720. So my answer would be 720 possible 6-letter combinations from a 6-letter word. Okay, now that's fun, isn't it? All right, now the fundamental principle of counting in a multi-step process where there are m different ways to do the first step. Okay, that's what we just did. There were 6 different ways, 6 different numbers I can choose for my first letter. And m sub 2 ways to do the second step. There were 5 different ways to choose the second letter, and so on. Then there are m times m1 times m2 times m3 times m4, all the way up, ways to do an n-step process. So that's basically what we just did. All right, now, how many different passwords are possible when the passwords contain 3 case-sensitive lowercase and uppercase letters are distinct, followed by 2 digits? Well, you know I have 52 choices for that first letter. It doesn't say I can't have duplicates, so I'm going to have 52 possibilities for the second letter and the third, followed by 2 digits, which there are 10. Now, mind you, 10 digits because we include 0. 1 through 9 plus 0, and 10 more. Now, when we multiply this all together, let's see, 52 times 52 times 52 times 100. For my answer is 14060800. It's a lot of possibilities. Okay. This is where we get into like license plates. The more digits, the more spots you have, the more letters you allow, the more combinations there are. All right, a tree diagram. This is another way to figure out the number of possibilities, okay? So, Brock has 2 pairs of pants. He can wear, sorry about that. He can wear, we're going to do highlighters. He can wear black or tan. Now, given that he has his black pants on, he has 3 different shirts. He has a gray, a white, and a red. But if he had his tan, he'd have a gray, a white, and a red shirt possibility also. All right, how many different outfits can he choose? Well, 1, 2, 3, 4, 5, 6. Right? He can have black, gray. He could have black, white. He could have black, red. He could wear tan, gray, tan, white, or tan, red. And that gives me 1, 2, 3, 4, 5, 6 possibilities. This is called a tree diagram. All right, the product of n and every natural number less than n is connotated by an exclamation point. This is called n factorial. The definition of n factorial is it should be n times n minus 1 times n minus 2 times n minus 3, all the way down to a 1. 0, by definition, 0 factorial is a 1. Okay, that's an important thing to know. Factorials are used to determine the number of possible arrangements of the members of a set. And that's what we're talking about, arrangements of the letters in a word kind of thing. All right. If 8 students are running a race, in how many different orders can they finish? Well, what are our options of orders? We have first place, second place, third place, fourth place, 5th, 6th, 7th, and 8th. So, if we're looking at this pool of 8 runners, one of them gets to be first place. So I have 8 people to choose from for first place. Okay, so I called Sam. Sam comes up, he stands up here. Now, how many do I have choices for second place? Well, how many people are still standing there? If Sam is up here with me and there were 8 to begin with, there's 7 left. So I have 7 choices for second place. Now, Destiny comes up because she came in second. So now I have how many people to choose from for third place? Well, there were 8, and then I pulled up Sam. 7, then I pulled up Destiny. So now there's 6. And this is going to work this way all the way down. This, remember, I don't know why I wrote a 7. This is your factorial. So your answer is these top numbers, right? So this is really 8 factorial. Now you have this in your calculator, 8 factorial. Okay, so if you, in your calculator, go get your calculator. Put me on pause if you don't have it with you. Okay, hopefully you have your calculator now. You do a math. Then look up at the top of your screen. It says Math Num CMPLX, complex, probability, what we're working on, and fractions or fractal or something. Anyway, whoops. So now we arrow over. That's what I was doing. Okay, yeah, fractions. Okay, you want to arrow to probability so that the probability has a black background. Now notice I have 1, 2, 3, 4, 5 through 8. We're going to be using mainly 1 through 4. Well, not even 1. We'll be using 2 through 4. 4, notice, is factorial. So if I go back out and I say 8, and then I type math, and then I arrow over to probability, and I choose the number 4, and that gives me an 8 factorial. I hit enter, and I get 40,320 possibilities of 8 students running a race. Now, we know that, there's other things that go into who wins besides totally random, but let's say it was random. All right. Now, we have a couple of things we use, and you saw them on that screen in your calculator. Permutations. A permutation is an arrangement of objects in which order is important. So, running a race. Order's important. Who comes first cares that they came first. They don't want to be thought of as coming last. Order matters, okay? Order matters if you can tell the difference. If I'm nominating people to be on a committee, who cares who gets picked first and who gets picked last? Right? We're just drawing names out of a hat. Doesn't matter. But if I'm nominating 3 people, one of which will be president, one is vice president, and one is secretary, it matters. They have different roles within the organization. So it's going to matter who is which. So that means order matters. Okay, so this is something you're going to have to learn how to figure out. Does order matter? Because you use 2 different formulas if it does or doesn't matter. All right, so in permutations, order matters. It is important. In other words, CAT is totally different than TAC or ATC, right? One spells cat, the others don't. They make up nonsense words on many of them. Okay, so order matters. This is written as NPR, and it's in factorial. Let's do it this way. We're going to in factorial permutations of take an R at a time. Whoops. All right, there we go. Here's R. Sorry, I was going to highlight just the R. Okay? This is how this works. So, this is also in your calculator. If you go back to your screen, this is what I want you to do. Type in a 9. 9. Now go back math, over to probability, and NPR is number 2, and type in 5. Type in 5. So what you should have on your screen right now is 9P5. All right? And you hit enter, it gives you that calculation. Ta-da! Okay? That's how you're going to use your NPR. All right, how many ways can 5 of your 9 favorite photographs be arranged on a shelf? So you have a stack of 9 favorite photographs. You don't care which 5 are picked, you just have to pick out 5. So, how many ways? Well, okay, let's floor the wood at the bottom here. That's our shelf. Okay, I have 1 picture slot, 2, 3, 4, and 5. Well, I have 9 ways to choose the first one. I have 8 ways to choose the second. I have 7, and then 6 and 5. So really what I have here is 9 items, photographs, taken, 5 at a time. So that's 9 factorial, but look at the bottom. That's not 9 factorial. 9, 8, 7, 6, 5. Where's the 4, 3, 2, 1? Well, let's look at that. This is 9 factorial over n minus r. That's 9 minus 5. I wrote the n instead. Silly me. Let's see what that means. Okay? So what I've got here is 9 factorial over 9 minus 5 is 4. So what I'm going to do is divide out those bottom 4 numbers, right? So that I can rewrite 9 factorial as 9 times 8 times 7 times 6 times 5 times 4 factorial. Because that's just 4, 3, 2, 1. That's the rest of the factorial. Now, if I have 4 factorial here, I merely divide those out, and I'm left with the 9 times 8 times 7 times 6 times 5. So I can put that in my calculator. Well, we just did 9 and 4. That was totally random. No, we just did 9 and 5. Wow, that's totally random. Okay, so this is 15120. We just figured it out. So that's your answer. That's how many ways you can arrange your five of your 9 favorite photographs. Okay. So, I'm sorry, I forgot a little doodad that makes this more comfortable for me to work. So there we go. I put my screen at a little bit of an angle. All right, moving on. In a permutation, order or arrangement is important. If the order is not important, we use combination. We have a combination and permutations. All right, we just saw permutation is NPR. Combination is going to be NCR, slightly different. Now, order is not important for combinations. Okay? So now we're going to look at what that means. Now notice you have gained something. In the permutations, you did not have this extra r factorial. What that does is divide out all of the ones that are duplicates disregarding order. Okay? So it's slightly smaller because order doesn't matter. I'm going to count CAT, and I don't need to count TAC or ATC. Or ACT, or any of the others. Okay. Now, practice a little bit with combinations. Find the number of different 5-man teams that can be made from 12 players. Okay, so I have, we want that, there we go. I have 12 players, and I'm going to take combinations of 5. I put this in my calculator. That was number 3 on the probability screen. So, I get out my calculator. Well, let's look at the math behind it first. So that's going to be 12 factorial over 5 factorial, 12 minus 5 factorial. Okay, so this is 12 factorial over 5 factorial and 7. 7 factorial. I'm going to divide out that 7 factorial. So I have 12, 11, 10, 9, 8, 7, 6, 5. Oops, I'm going to divide out the 7. So I really only need to go to there. 7 factorial. Well, I have 7 factorial, and I'm going to divide those out. Then I have 5 factorial, which is 5 times 4 times 3 times 2 times 1. 1 doesn't matter. All right, 5 and 2 is 10. So I can get rid of that one. 4 and 3 is 12. So I can get rid of that one. So really what I have is 11 times 9 times 8. Or 99 times 8. So if you do that, you can cross things out. It's really not so difficult. So that's 792. Okay, so not too bad. So you can do that with a regular calculator if you don't have your TI-84 with you. TI-84 just does make it a little simpler. All right, now last example. How many different pizzas can be ordered? Woohoo! pizzas by choosing up to 3 of 8 available toppings. So if I have 8 toppings, I'm going to choose 3. Now, order doesn't matter because I personally don't care if you put my pepperoni and then my sausage and then my mushrooms, or my mushrooms and then the pepperoni and the sausage, or then the mushrooms and then the sausage and the I don't care. So order doesn't matter. So I use C, use combinations. Okay, so this is going to be 8 factorial over 3 factorial. 8 minus 3 is 5 factorial. So I have 8, 7, 6, 5 factorial. Now I have 3 times 2 also. Well, that's 6. So really I have 8 times 7. Don't I? So I have, what is that, 56 possibilities. There we go. All righty. Oh, I didn't write your homework on here. Oh, that's terrible of me. Okay, hang on 1 second, and I will go look it up real quick for you. Actually, I have it in my file somewhere. There's my file. Okay. Homework. Grade sheets. Homework. 13. 3 through 36 or 1 through 37. Ah, I'm losing things. All right. Okay, so we have regulars, 3 through 36, and honors are 1 through 37. There we go. Apologies for not getting that on there. All right. There we go. Have fun.